Welcome to video 4. Today we're going to be talking about stretching of mixed functions. So we're going to look at the function f of x equals the absolute value of x, which is graphed on the graph here. We're going to fill out the table for each function below and then graph and label them on the axes. So if we have g of x equals 4 absolute value of x, we're going to put this in our calculator. So y equals 4, and then we need to hit the absolute value bars. If you forgot how to do that, in your calculator, you need to hit the math button and then over to num at the top. The first option says ABS, that's absolute value. So you're going to hit enter on that. Then you can put in your x and either close your parentheses or get out of the absolute value depending on what calculator you are using. Once you've done that, if you go to the table of values, you should get the same as the ones I am writing on the screen. So you can see here again, I just got this from my calculator. We have -2 with 8, -1, 4, 0, 0, 1, 4, and 2, 8. And then we can go ahead over to the grid and graph those and connect with a nice straight line on both sides. Okay, so once you've done that absolute value, we're going to do the same thing with the next one, putting h of x in y equals, getting our table of values, writing them down, and plotting those points. So when we go to our table of values, we get this 1, 0.5, 0.5, and 1. These are very small values, but we can still connect with the straight edge going out in either direction so that we have the nice V shape that we know an absolute value looks like. Then make sure that you label it h of x because all of these different functions on one grid, we need to know what each one is. And lastly, the same thing for j of x, we're going to plug in y equals -2, math over to num, absolute value of x, and then close our parentheses or get out of the absolute value bars. And we can go ahead and get our y values for these x values again. And when we do that, we get -4, -2, 0, -2, and -4. And then again, I'm going to go ahead and plot my points and connect with the straight edge in either direction so I again have the nice V shape for an absolute value graph. So now that we have all these graphs, we can answer the questions. What happened to the graph g of x equals 4 times absolute value of x? Well, if we look at that compared to our original parent function, that graph is more narrow. It looks like it got stretched upward. And then for h of x equals 1/2 of the absolute value of x, that one looks like it got pushed down or wider. And then what happened to j of x? Well, that one reflected over the x-axis and is more narrow. So looking at all of these functions graphed here should be able to tell us what happens when we have these different values in front. We're going to notice general things here that we're going to apply with some rules that will help us whenever we see numbers out front and whenever we see that negative out front to help us know how to handle those numbers and what type of transformation those are. So what are our general rules? Whenever the k number is greater than 1, the graph is vertically stretched, and we're always going to talk about these things being stretched by a factor of k. When this happens, when k is greater than 1, the graph will look more narrow. And that'll always be the case because we're taking this graph and spreading it over a further area. When it's between 0 and 1, the graph is still vertically stretched by a factor of k, but this time the graph will look wider. So I wrote that as being more wide because it's being compressed down. The space for it is taken to a smaller amount. And then if k is negative, that's always going to mean that the graph is reflected over the x-axis. And we'll talk about these more in class and examine them a little bit more. So we'll see you tomorrow.